Hi everyone. In this lesson, the second part of the video of the lesson 7.5, we're going to learn how to graph the transform sine and cosine function. So you see that we have a function here, 4 cosine of theta minus 10 plus 1. The parent function was y equal to cosine of theta, but there are some values added and subtracted to this function, so the function will be transformed. So as you see, we have a number multiplied by the function right before that. Uh, that number is greater than 1. So we're going to have a vertical stretch. This vertical stretch is going to change the amplitude of the function from 1 to 4. So that's a new amplitude. Then you see that theta is subtracted by 10. So that's going to move the function right 10. That's the phase shift. So that means the starting point, instead of being at 1, at 0, it's going to be at 10. So the start point is 10 on x-axis. Then a number is added to your function. This is going to move the function up 1. So the sinusoidal axis, which was at 0, now it's going to be at y equal to 1. Notice that no number is multiplied by the theta. Like here, the parent function doesn't have anything. Here also doesn't have anything. So the period has not changed. We're working with degrees, so the period will be 360 degrees. It's not going to change. But what are the critical points? First, you divide 360 by 4. That's 90. This is the step between the critical points. Now, what are critical points? You start from 10, and then to go to next critical point, you add 90 to that. So this will be 100. Plus 90, 190. Plus 90 is 280, and plus 90 is 370. So these are the critical points. Now we're going to start with graphing the critical points here. At y equal to 1. So this is the sinusoidal axis. Now label your sinusoidal axis with all the critical points that you found. So here I have 10, 100, 190, 280, and 370. Now what is the highest and lowest point? Amplitude is 4. So from the sinusoidal axis, you go 4 up. So this is going to be at 5. And from sinusoidal axis, you go 4 down, 1, 2, 1, 2, 3, 4 down. So this is at -3. So these are the highest and lowest ones. Now we know that the parent cosine function starts from a high point. It looks like this. So the first critical point will be at 10 and a high point. Then you have a middle point. Then you have a low point. So the next critical point will be here. Next critical point will be middle. Then it will be high point. So because you have high, middle, low, middle, high. So this will be the graph of your function. The next graph that you see here is exactly the same thing that we have here, except that we have a negative here. So everything, all the changes will be the same, but we have a negative here. This is going to be a reflection over x-axis. So we have the same values. I'm going to make everything the same way. And we have critical points, 100, 190, 280, 370. And the highest point is at 5. Lowest point is at -3. But except that here, I need to reflect this function. That means any high point now will be a low point. Any low point will be a high point. But the middle points will be the same. So instead of starting from a high point, I start from a low point. Then I have mid, then I have high point, middle point, and then low point. So this will be the graph of my function. So as you see, it's the same thing that we had here. It's just reflected over the x-axis. Now let's look at this one. The number which is multiplied by your function right before the function is going to change the amplitude. It's a vertical stretch here because the number is greater than 1. So amplitude is 5. A number is added to your function, to your theta. This is going to move the function left 150. So the start point will be at negative 150 because from 0 you go 150 to the left. Then this value could be written after the function or it could be written before the function. Anyway, it's outside of the cosine. So this is going to move your function down 3 because it's a negative value. So your sinusoidal axis will be at y equal to negative 3. Now let's look at this value. This is a number which is multiplied by your theta. It's after the name of the function and it's right before the theta. So this is the b value that is going to create a horizontal stretch or compression. Since this value is less than 1, you will have a horizontal stretch. So let's see how. The period of the function will change. So you're going to divide the period of the parent function 360 by this b value 2 over 3. So you write it as 360 times 3 over 2. Keep, change, flip. So this is going to be 540. So the period of the function is 540. Now we're going to find the critical points. First, you need to find the steps. So you divide 540 by 4. 540 divided by 4 is 135. So that means the steps between the critical points is 135 degrees. What is the start point? It's at negative 150. You add 135, it's going to be negative 15. Add 135 to get the next one. So negative 15 plus 135 will be 120. Again, to find the next one, add 135. That's 255. And add another 135. That's going to be 390. And we have 1, 2, 3, 4, 5 critical points. This is enough for one cycle. Now let's start graphing the function. The sinusoidal axis is at negative 3. So let's say here is y equal to negative 3. Y equal to negative 3. Now, consider the amplitude. From the sinusoidal axis, you go 5 up. 1, 2, 3, 4, 5. So at 2, you have the highest point. And you go 5 down. 1, 2, 3, 4, 5 down, which is at negative 8. You will have the lowest point. Now, we're going to label the sinusoidal axis with the critical points. So here I have negative 150, then I have negative 15, then 120, 255, and 390. Now I'm ready to graph my function. Cosine function, as you know, looks like this. High point, mid, low, mid, high. So the first point, critical point, is a high point. Then you have middle. Then you have a low point at negative 8. It was right here, sorry. So it's here. Then you have middle point, and then you have a high point. Now you're going to create the curve Connect all these points. So this is your function. Okay, now let's look at this function. This time we're working in radians. So we have 5 minus 6 cosine of pi over 5 x minus 2. First of all, this 5, which is outside of the function, this is going to move the function up 5. Sinusoidal axis will be at y equal to 5. Then you have a number multiplied by the function is greater than 1. So this is a vertical stretch. Amplitude will be at 6. You have x minus 2, or this is basically your theta. Doesn't matter, we called it x here. So this function is moving your function 2 to the right. So we have a phase shift of 2 to the right. So the start point will be at 2. At 2 on x-axis. The period of the function. Since the function is in radian, to find the period, you're going to divide 2 pi by pi over 5. So you do keep 10 flip. So this will be 2 pi times 5 over pi. So the pi's cancel and it's going to be 10. So that's the period of the function. Now to find the critical points, you need to find the steps first. Then the period of the function divided by 4. So it's going to be 2.5. So these are the steps between the critical points. So what are the critical points? You start from 2, and each time you add 2.5 to that. So it's going to be 2, 4.5. Then add 2.5 to that. That's going to be 7. Add 2.5. Add 2.5. This is 9.5. Add 2.5 to that. That's going to be 10, 11, 12. So we have 1, 2, 3, 4, 5 critical points. Now we can start graphing the function. But notice here we also have a negative behind the 6 here. So we said if a value is negative, we have a reflection over x-axis. So I start with graphing the function at y equal to 5. Let's say this is 5. Y equal to 5. Now I'm going to graph the critical points starting from 2. So let's say this is 2, then this is 4.5, 7, 9.5, and 12. Now, what is the highest point? Amplitude is 6. So from 5, you go 6 up. So here at 11 is your highest point, and 6 down at -1 is your lowest point. Now I'm ready to graph the function. Cosine starts from a high point. So the function is supposed to be like this: high, middle, low, middle, high. But because the function is reflected over x-axis, the high point will be reflected over x-axis. So I'm going to graph the function first with dotted line, which is something like this. But then I'm going to reflect this because of this negative. So high point will be low, middle will be the same, low point will be high, middle is the same, and high point will be low. So this is the graph of my function. Okay, let's look at the next one. Again here, this 1 is going to move the function up 1. This is the vertical stretch. The 2 is vertical stretch. So the amplitude will be 2. The up 1 will change the sinusoidal axis to y equal to 1. This is going to move your function 5 right. So start point will be 5 on the x-axis. Now this is the b value. So the period of the function will be compressed. It's going to be shorter because this value is greater than 1. How? We're working with degrees, so you're going to divide the 360 by 10. So it's going to be 36. That's the new period of the function. Now we're going to look for the critical points. Divide 360 by 4. That's 9. I'm sorry, divide 36 by 4. I'm going to write that again. Sorry. So steps will be 36 divided by 4, which is 9. So this is the steps between the critical points. The first point is 5. So you add 9 to that, that's 14. Then you add 9 to 14, 23. Add 9, that's going to be 32. Okay, now I'm going to add another 9, and 41 is my last critical point of one period of the function. So we start with sinusoidal axis, which is at y equal to 1. Then label the sinusoidal axis with the critical points 5, 14, 23, 32, and 41. Now, the highest point from the sinusoidal axis, you go 2 up. So this was at 1, 2 up is going to be 3, and 2 down will be at -1. These are the highest and the lowest points. Now, we have a sine function. We know that sine looks like this. Starts from a middle point, high, middle, low, middle. So this is sine. So the first point will be a middle point. Next one is a high point at 3. Then we have middle point. Then you have low point and then middle point. So this is the graph of the function. Now let's look at the last one, this function. The first thing that you have to notice here is we have the function which is moved up 1, and also we have a reflection over x-axis because there is a negative. And then here you see that the 2 is multiplied by x. So you might think that we have a horizontal compression, which is right, but we need to change this function in a form that looks like all the functions that you see here. Like there is a number, then you have parentheses, then x minus something. So this number, which is multiplied by your x or theta, should be behind the parentheses this way. Or if I show you the general sinusoidal function, looks like this: b parentheses theta minus c. Looks like this form, but this function is a little bit different. So we need to change it to that form. How? I'm going to factor the 2 out from these two values. So the function is going to change and look like this. Y equal to negative sine of 2. I'm going to factor the 2 out from the first one. So you divide by 2, you're going to have only x here. And you divide this one by 2 as well. What is pi over 2 divided by 2? You do keep, change, flip. So it's pi over 2, change, and flip the second one. This will be pi over 4. So you will have plus pi over 4. And then you have a plus 1 here. So this is the original form that your function should look like, the transform function. The b value should be behind the parentheses, and then the phase shift should come inside the parentheses with the x. So this is your b value. That means this one is the phase shift. Your function is moved left pi over 4. If you had not factored the 2, you would say the function is moved left pi over 2, but this is right. So your first point, a start point, will be at negative pi over 4. The amplitude of the function will remain the same as before, which was 1, as the original one. Amplitude is 1. Sinusoidal axis is at 1 because the function is moved up 1. You have a reflection over x-axis here. And now, what is the period of the function? Because we're working with radian, you divide 2 pi by this b value by 2. 2 pi divided by 2 is equal to pi. Now, the steps of the critical points is pi, the new period, divided by 4. So that's just pi over 4. These are the steps between the critical points. The first point is at negative pi over 4. Then you add pi over 4 to this, that's going to be 0. Add another pi over 4 to 0, that's pi over 4. Add pi over 4 to this one, so it's pi over 4 plus pi over 4. That's going to be 2 pi over 4. So I write 2 pi over 4. Then add another one, it's going to be 3 pi over 4. You can simplify 2 pi over 4 as pi over 2 because it's too simplified, but I'm going to keep it the same way. Now I can graph my function. Sinusoidal axis is at y equal to 1. The highest point, you go from the sinusoidal axis 1 up, so at 2 is the highest point, and 1 down at 0 is the lowest point. Let me graph the function with a different size so it looks better. So I consider the y equal to 1 here, y equal to 1 here. So I go 1 up here and 1 down here. This is 2, this is 0. Now, the critical points are at negative pi over 4, 0, pi over 4, 2 pi over 4, and 3 pi over 4. Okay? 2 pi over 4 and 3 pi over 4. Now I'm going to start graphing the function. We have a reflection over x-axis. So I know that the sine function looks like this: middle, high, middle, low, middle. So I can do that, but I need to reflect this over x-axis. That means the middle point will be the same. High will be low, then middle, low will be high, and middle is here. So this is your reflection of the function. So you start from a middle point here. Then you have a low point. So at 0, you have a low point here. The next critical point is a middle point. Then you have a high point. So next one is high, and then you have middle. So this is reflected, and it looks like this. Okay. So this is a practice of graphing sinusoidal functions which are transformed. I hope it was helpful for y'all. Have a great day.